So the first thing to do is to upload the code to the iMech board. I recommend you use a USB A to C, as it seems to work more reliably. Every now and then there is also an issue where you need to flip the USB connector 180 degrees, and that fixes some connection issues. So upload the code via Thonny. If you're having trouble with this, there's a whole written tutorial that I have, and I'll link in the description. This time there's also a second file you'll need to upload to the driver board, and that is a driver for the servos, and so you want to save that to the board and call it servoclass.py, all lowercase. Next, you want to load in the facial recognition model into the Seed AI board. So the easiest way to do that is to go to the Sensecraft website, select the Grove Vision AI V2 board, select the face detection model, click deploy, select your board, and then here you can test it out. You can play with the confidence threshold and experiment a little bit to see how it works. And then when you're ready, you can load that on and it will be ready to go. So first of all, you can start by placing in the two eye servos. It should be obvious which way round these go because there's a little slot for the wire to pass through. You won't need any screws, they're held in with a snap fit. If your printer's a little bit less accurate, or maybe you have some support left in there, you might also need to take off the stickers from the servos. And there's the third servo you should put in before anything else. I actually filmed this out of sequence because I only remembered later on. But you want to put on the smallest gear onto this servo and place it inside of the head, and this is the servo which controls the pitch of the head. So next up is the soldering for the power system. Now for safety reasons, I'm going to recommend that you don't use the battery because this project will run fine on a USB connection, but for informational reasons I will show you what I did, and that was to connect the battery to this 2-cell LiPo USB charger, connect that to a 5-volt regulator to reduce the voltage supplied by the battery, and then wire all that into the PCB. And I also wired on a little switch so that I could turn off the battery, of course. Note that I also soldered on header pins for the 3-volt line, a ground pin, and the TX and RX, which are on 0 and 1. Once you have all of this soldered up, the next step is to fix it into the model. So I started by attaching the battery to this top part. You can use zip ties. I didn't have any, so I used some cable and just twisted it around. As long as it's held securely, it will be fine. Then you can fix the charging board. In the video, I'm actually doing it the wrong way around. It should be 180 degrees from there, and you can screw it in place. And then the 5-volt regulator I held in place with a little bit of hot glue. You can then clip the board in position, make sure that the USB is facing downwards. Then I started working on the base. This is the one servo that does require screws to hold it in place, so you can slot it through the hole. Again, it's obvious which way around it goes because of the wire, and then you can put in some screws to hold it in position. You can put on the gear. This is the straight toothed gear, and that will be a tight fit, but that's a good thing. And then you can put the screw in and make sure it's really good and secure. Next, you need to add the clip on the gear, and it's really important to get this the right way around. So if the servo is on your left, the teeth of the gear should be pointing upwards, and just really check and make sure you've got that right because this will be hard to change later on. Next, you can assemble the bearing race. So the way to do that is by placing all of the rollers into the inner race. This is an older prototype that's a little bit thicker. Yours should go in a little bit easier than mine, and then clip on the outer race. Place that onto the lower part of the bearing, make sure that it rolls smoothly, and then put all of this on the top of the bearing. Now by plugging in the servo to one of the pins, you can test that it's working, and if you're sure it is, you can clip on the bottom part to hold everything in place. Now we're going to put the camera inside the eyes. Just make sure it's in the same orientation that it was when you uploaded the model to the AI board. So in my case, that meant the cable had to come straight down first and then back up and loop in over the battery. That's because the model only works properly when the faces are the correct way up. And then to hold it in, we clip in one of the gear arcs and make sure you get them the right way around, because the long ends of the gear arcs face outwards. Just make sure you have that right. Then you want to put on these small rotating clips. This is something that I should have made symmetrical, but for now I have not, and so you should check that the side you printed face down on the bed, which is the rough side, is facing downwards on the model as well. clip the eyes in, make sure that everything moves smoothly, and then you can route that FPC up through in between the battery and the housing so that it's secure, and it can also rotate, and then you can start to route it through the PCB. Now I've put a clip in here which you didn't see me put on, but it just clips on really easily, and that's what's going to hold the AI board. But the FPC needs to just route over that clip. You then need to attach the adapter, which converts from a 22-pin CSI cable to a 15-pin CSI cable. You fold that over and clip it into the lowest stage on that little clip, and then you can add the 15-pin CSI connector, clip that down, and attach it to the AI board. Just make sure that your pins are the right way, make sure that they're facing down into the thing. You should be able to see as you're doing it, just make sure. Loop that over and clip it in securely. And now we're going to do the eyes. So attach the eyes, the left eye to the first socket and the right eye to the second socket. Make sure the switch on the board is set to the hold position. So that is going to calibrate the servos to 90 degrees so that we know when we come to put the gears on, the eyes should be facing straight forwards. So put those gears in, making sure the eyes are aligned. Again, it's a bit tight, so you have to push down pretty hard to get those on. Make sure you have them the right way around because they are mirror images of each other, and put the screw in too to make sure it's secure. And then we can work on the blink mechanism. So add that remaining gear onto the servo, should be nice and tight. The screw should be nice and secure, and then you can put your eyelids in. Now these are the white eyelids. I printed them white because it's going in the skull, but if you were to do the pumpkin, obviously would print these in orange, and make sure they clip in and move nice and smoothly. You want to calibrate your eyelids to the position you want to be the resting position, further down if you want it to be sleepy or moody, and then clip that servo in, and that will calibrate it to the eyelid's resting position. And then finally you can clip on the base, make sure the angle of the head is completely flat and not tilted up at all. And then I used my multimeter just to quickly check that the voltages were being converted correctly, and we were getting 5 volts to the servos and we were getting 3.3 volts to the AI vision board. And I used a multimeter from Alien Tech, which is a really cool product that I like. So when I was sure that the Seed AI board would be getting the 3 volts that it needed, I connected up the power line, the ground, and also the TX and RX pins. So remember, TX goes to RX and RX goes to TX. And on my board, TX and RX regretfully have not been labeled, but they are 0 and 1 respectively. So 0 is TX and it goes to RX on the AI board. On my board, pin 1 is RX and it goes to TX on the AI board. So when I first got this working, it was moving the wrong way, so it was avoiding eye contact at all costs. And the reason that happened was because I had the camera in the other way around when I first programmed this. So this is a better way around for the camera to be. So I changed the code. Instead of trying to adjust left, it would try to adjust right. So once I got it working with the code properly, it was pretty simple to secure on the shell, and then it was ready to go. If you want to get the CAD files, including the entire design history and the bosses and exclusion zones, which you can use to make your own custom shells, you can get access to all of that on my Patreon page, and you'll be able to access that at any tier.